Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakam bin Muhammad Yusof. I'm from AS120. I'm student Diploma Science Sem 1, Semester 1. I want to present to my lecturer Chapter 7, Chemical Equilibrium. So, the reaction mechanism is the order which bonds are broken and form and change in relative position of the atom as the reaction proceeds. Reaction rate is the change in the concentration of reactant or product with time. Reaction rate are affected by temperature, concentration and catalyst. So, reaction rate for temperature is high temperature implies higher average kinetic energy of molecule and more collision per unit time. Thus, the reaction rate is high. If low temperature implies lower average kinetic energy of molecule and less collision per unit time. Thus, the reaction rate is low. So this is the example for temperature. So next is reaction rate for concentration. For low concentration, less frequent collision between reactants, slower reaction. Different with high concentration. If high concentration, more frequent collision between reactant, faster reaction rate. So on the left side is the diagram for low concentration reaction rate and high concentration reaction rate. So this concentration, increase concentration to increase in frequency of collision and increase reaction rate. So the next is reaction rate catalyzed. Catalyzed is a substance that increase the rate of a reaction without itself being consumed in the reaction. So on the graph is potential energy by reaction coordinate. If the reactant will not put a catalyst, the graph is this is the graph for the reaction rate catalyzed by potential energy reaction coordinate. So the next is table for easy to remember the reaction rate for concentration, temperature and catalyzed. So effect in the reactant for concentration is increase in reactant concentration, increase rate. If decrease in reactant concentration, decrease rate. For temperature effect in reactant is increase in temperature. If increase in temperature is increase rate, the increase rate is increase. If temperature decrease, so the increase in temperature rate, decrease in temperature rate, temperature decrease rate, increase in temperature, increase rate, decrease in temperature, decreases rate. So for catalyzed is effect increase reaction rate, effect there. So next is the concept of equilibrium. Most chemical reactions are reversible forward reaction for products, while reverse reaction from reactant. This happen at the same time until chemical equilibrium is achieved. chemical equilibrium is achieved when the rate of forward and reverse reaction are equal and the concentration of the reactant and product remain constant. For the characteristic of system in equilibrium is a dynamic process. Equilibrium occurs in a closed system. The rate of the forward reaction equal to the rate of reverse reaction. So both reactions occur until the concentration of reactant and product reach constant value. So the next is the reaction vessel contains both reactant and product and is said to be a state chemical equilibrium. So this is the system at equilibrium. Both the forward and reverse reaction are being carried out. As a result, we write the equation with double arrow. So this is a diagram for iodine gas, hydrogen gas, and hydrogen iodide molecule. When the hydrogen and iodine are taken in a closed vessel maintained at 717 K, hydrogen molecule combine with iodine to form hydrogen iodide. The molecule of hydrogen iodide form also begin to dissociate to form H2 and I2, gas hydrogen and gas iodine. So this is the graph for reaction rate by time. Rate of forward reaction slow down due to the concentration of H2 and I2. Gas hydrogen and gas iodine decrease. Concentration of hydrogen iodide increase, thus the rate of backward reaction increase. Equilibrium state is reached when the rate of backward reaction equal to the rate of forward reaction. So this is chemical equilibrium. The forward reaction goes to the right and the reverse reaction goes to the left. At the equilibrium rate of the reverse reaction and the reverse of the reverse reaction equal the rate of the forward reaction. The equilibrium constant is K. Consider below. So this is a formula for equilibrium reaction. Okay. Small a, capital A plus small b, capital B equal small m, capital M plus small n, capital N, where A and B are reactants, M and N products. A, B, small, that's for capital letter. For small letter, A, B, M, N is coefficients. Coefficient for the balance equation. At equilibrium, the composition of the reaction mixture obey an equilibrium reaction. So this is the equilibrium reaction. Kc indicate the concentration of the reacting species are expressed in a molarity or mole per liter. Kc expressed applies only to gases and aqueous substance. So this example, the formula for Kc is concentration of reactant of the reacting species. So this example for reactant to find the Kc, constant equilibrium. For the constant partial pressure, Pc is partial pressure of C in atom. C is number of C mole of mole of C. Kp indicate the equilibrium are expressed in terms of partial pressure. Kp expression applies only to gaseous reaction only. So that's is equation for to find the Kp, partial pressure. Homogeneous equilibria. Homogeneous equilibria are equilibria in which all substances are the same state or phase. Example like this. Before and after the reactant is gaseous. This also for the heterogeneous equilibria is a equilibria that involve more than one phase. Example, calcium carbonate is S is what there is two phase. S and G is gases, S is solid. The position of heterogeneous equilibrium does not depend on the amount of pure solid or liquid present. So the Kc for heterogeneous equilibrium is CO2 only, because get only gases, Kc only gases or aqueous. For indicate whether so the A is homogeneous and B is heterogeneous, C also heterogeneous. Thank you.